Hi everyone, let's solve this problem matchsticks to square. You are given an integer array matchsticks where matchsticks of I is the length of the ith matchstick. You want to use all matchsticks to make one square. You should not break any stick, but you can link them up, and each matchstick must be used exactly one time. Return true if you can make this square or false otherwise. So let's try to understand this problem and solve it. So before even we come up with a solution, let's understand couple of things. The total sum here is 8, and if total sum is not divisible by 4, that means we cannot form a square, and length of square side is equal to total sum by 4 because there are 4 sides. So 8 by 4 will be 2. These are couple of properties which we need. And then a particular square will always have top, right, bottom and left. So we have to check all the sides and we have to place our matchsticks accordingly. So we have 1, 1, 2, 2, 2. Let's say initially I start with 1, and as I mentioned, I'm going in top, right, bottom, left order, but you can use any order. So I have picked up 1 and I can place it at 1, and then again I'll place 1 at the top, and I cannot place any more sticks on top because I have actually reached the limit of 2. And then I will explore the other path, right? Once the other path, here the path is 2. I cannot explore this path anymore because we have reached the limit. Now I am exploring the other path. Other path is nothing but the right. So basically top, right, bottom, left. These are the paths. So I'll get 2, and we cannot explore this path any further in the sense like we cannot add anything on the right side of it. We can explore the path, but we cannot choose the right matchstick. Let's say for example here again, if there are 4 branches, we cannot go to left, we cannot go to top, we cannot choose right, we can choose bottom, right, because already top and right are already done. So we will choose the bottom. When we choose the bottom part, we can place the matchstick of length 2. This is done. Now again there will be like 4 variations: top, right, bottom, left. So in this particular path, we have already got top, right and bottom. Now we are looking for the left. So in this case, top, right, bottom are not valid anymore. We have to search for the path which is left, because any value in these sides will exceed this condition, and then we will have a left of side 2, right? This will form a square. So once we found a path with all the sides of the required lengths, we will stop there itself. We don't have to iterate even further. So let's try to write the code for the same and see. Initially we'll calculate the total sum. Okay, total sum plus equal to the matchstick. If total sum divided by 4 not equal to 0, then we'll return false from here itself, and then we'll get length of the side is total sum divided by 4, and then we will have sides to store the sides value const sides. This will be array of size 4 because we have 4 sides. Initially we'll have 0 in every cell. Then we will also determine a backtrack function which will determine the index. Index is nothing but the index which we are going to use to track the matchstick where we are currently, like which matchstick we are using, and we will call the backtrack with the 0th index. And now in this case, if index reaches the final index of the matchsticks, that means we have placed all the squares properly, so we are going to return true from here. Otherwise we will iterate over all the sides. There are 4 sides, and we will check if sides of I plus the current value we are at the index is less than or equal to length which we have computed. This length of the square side, length of the square side is what we have computed already. If this is the square, if this is possible, then we will add plus equal to, right? Basically when I have placed this particular side with 1, side of top is nothing but, let's say 0 is added to 1, right? How are we going to calculate this less than or equal to 2 is based on the value in the sides array, and this is the index. Now we will call the backtrack with the next index, right? Because we have already placed the matchstick. Now if this is possible, we will go further to the next matchstick, and if that particular any backtracking particular solution returns true, then we will have to return true from there itself, because we don't want to explore all the paths, and if we find one path, we are good with it. If not, whenever we are checking the other path, then I have to remove my value from the sides, and then at the end we will return false because we could not find any solution. So let's try to run this. Good. So this part where we have to remove, this is like the backtracking, we will add and remove, right? Whenever we are like backtracking, let's say for example in this particular solution we did not get any solution, that means if I am removing this, I'll have to remove the value from my sides of 0, the top. So if I've added 1, I will be adding 1, right? So I'll be removing 1 and making it 0 when I am like exploring the other paths. And there is one catch here, it will throw a time limit exceeded. Let's try to submit it. Yes, this is because we can actually do one optimization on this. This is nothing but sorting the matchsticks in the reverse order, so that if we sort the matchsticks in the reverse order, if the solution is not possible, we are kind of, so let's say for example I am trying 1 1, right? 1 1 and exploring, but if I have like larger number, let's say for example the length the array also has a 4, okay, 4 side is never possible. So we can actually avoid a lot of recursion stacks and iterations to like figure out if the square is possible or not. That is the reason we kind of sort it in the reverse order so that it will work. So this is the solution, and let's also understand the time and space complexity. Time complexity of this solution is big O of 4 power n, and the space complexity of this solution is big O of n, because we are using the recursion stack of length n, right? We might go deeper. So for example, here we 1 2 3 4 5, so we have been to a path where like the n is 5 and the recursion stack is of also length 5. So this is the space complexity. This is for the recursion stack, and sorting will take n log n, but comparatively 4 power n and n log n does not make much sense. Like it will be much lesser than 4 power n. So n log n, you can also add it. I hope the solution is clear. Thank you.